Alright, so here we are, proof video number 3. If you need a little help, especially with number 5, this is a good one to look at. So we are going to do number 6 in your packet. So usual deal, why don't you guys go ahead and pause and write in the givens while I do the same thing. Alright, the givens are in. So let's mark in what we know. We know angle ACB is congruent to angle FBC right there, FBC. We know AD right here is congruent to CD right there. And we know FB is also congruent to AD. So right away, I see AD shows up twice. So let's keep that in the back of our mind. So let's mark that last one in. FB congruent to AD. Now since AD already has one line of congruency there, we're not going to put 2 for FB. We're going to keep those all as single congruency markers. Alright, so let's see. We've used this given. We marked those in. There's no bisectors, no perpendicular lines, nothing like that. So let's make sure we know what we're proving. We are trying to prove that triangle CDE is congruent to triangle FB or BFE. So let's kind of take a look at those. This triangle right here, congruent to this triangle right here. So there's our two triangles. So right away we kind of see it's a bow tie proof. It's a little sideways, but it's still a bow tie proof. So before we do anything else, let's just get that out of the way. So we know bow tie proof. Usually we're going to have those vertical angles. So let's say that angle CED, remember the vertex has to be the middle letter, is congruent to triangle FEB, to angle FEB, excuse me, not triangle, FEB. And the reason is vertical angles are always congruent. All right. Mark it in. This angle gets 2 arcs. There we go. And looking at this picture, we have our vertical angles. It was given to us that angles C and B were congruent. And now it looks like CD is congruent to FB. It looks like there's our third piece already. But keep in mind, those two haven't been linked together yet. But it looks like they can be. Here's our key. Right there. So we know, since AD is the same size as CD, you know, we can make anything up like I always show you guys. We can call it 3 and 3. We know FB is the same as AD. So we can call FB 3 as well. That means they're all 3. That means they're all congruent to each other. So that tells us that segment CD must be congruent to segment FB. So since those are all the same, these are all congruent to the same thing. CD is congruent to AD, FB is congruent to AD. That means CD is congruent to FB because of substitution. And once again, that's why you mark your picture. So I've been saying there's a couple different ways for the substitution. If you have the 3 different pieces all with the same congruency mark, that's a clue to use substitution. Or if in your proof you see 2 different, let me say it again, 2 the same segments congruent to different things. So AD, same segment, congruent to 2 different segments. That means those 2 different segments are congruent. So we look at our picture. We have an angle and an angle. We have an angle and an angle. And we have our 2 sides. So let's name it in the shortest possible way. We have our 3 pieces. Angle, angle, side, congruent to angle, angle, side, right there. So it looks to me like we are done. Triangle CDE is congruent to triangle BFE, and naming it the shortest way, that is an angle, angle, side congruency. Alright, so there you go. That would be a good time to try out number 5, see how you do, then come up and check your work with me. Otherwise, you can move on to the next video if you think you still need a little bit of extra help, which is fine. Good luck.